Hello.
Yes, sir.
Screen is it visible now?
Yes, sir.
Okay. Today, any doubts are there first?
No, sir.
Okay. So today topic is order of a reaction, integrated rate equation, and half-life of a reaction. Here, formulas will come and numericals are there from these topics. First, order of reaction. Order is defined as the sum of powers of concentration of the reactants in the experimentally derived rate equation or rate law expression. Order of reaction is experimentally determined and is not written from the balanced chemical equation. Order of the reaction can be whole number, zero, or fractional. Yesterday, already I told you A plus B is giving product, suppose. Then the rate is equal to K into A to the power of X and B to the power of Y. In generally,
Yes.
A to the power of A it should be, B to the power of B, but it is not mandatory. Sometimes A equal to X may or may not be. May or may not. Okay. Similarly,
Yes.
Y equal to small b may or may not. Sometimes it will be same or different also. Not sure. So how we will get this X and Y? That is experimental data. Experimentally we will get it. Then what is the order? The order is equal to X plus Y. The order is X plus Y. Then what is this? This representation? This is the rate law. This is the rate law. Once again, you can see order is defined as the sum of powers of the concentration of the reactants. See, these are the reactants, these are the powers. Sum of the powers. This is the order. In the experimentally derived rate equation. This is the rate law as well as rate equation also. It is also known as rate equation also. Or rate law expression. Order of reaction is experimentally determined. Yes. And it is not written from the balanced equation. From this balanced equation, we cannot derive. Order of reaction can be whole number, zero, or fractional. This X plus Y equal to, it may be zero, it may be half, 1, 2, 3, like this. Okay, this is clear.
Yes, sir.
Next, zero order. The rate of the reaction does not change with the concentration of the reactants. The rate of the reaction does not change with the concentration of the reactants. That is zero order reaction. See, simply rate is directly proportional to, see, A is giving the product. Okay. A to the power of 1. Simply rate equal to Ka is there. A to the power of 1. What is this K? K also I'm not keeping. Yes. Okay. R for rate. Rate is directly proportional to A is there. That means when you are increasing the A, rate also increasing. This is the mathematical meaning.
Yes, sir.
If you increase A 2 times, if you increase the A 2 times, then how many times rate will be increased?
2 times.
2 times. So when you are increasing this 2 times, this is also increasing 2 times. That is, so rate is here first order. This is called first order. So how we are deciding first order? Very simple meaning. This a to the power of 1 is there means that is first order. So case 1 over. Suppose rate is directly proportional to B. Now I am increasing this B 2 times. Okay, suppose rate is increasing 4 times. Rate is increasing 4 times. Then what will it is the second order reaction. It is the second order reaction. How is second order reaction? Generally, the representation will be like this. B square. If I increase the rate of the B, if I increase the concentration of B double, then the rate will be 4 times. Yes or no?
Yes, sir.
Because suppose B concentration is X is there. Okay, X square. That means X square. So B concentration I am increasing double. That means 2x whole square. That means 4x square. So 4 times increasing. Understood now?
Yes, sir.
When I am increasing concentration 2 times, the rate is increasing 4 times. The 4 I can write like this also, 2 square.
Yes, sir.
So here I am increasing 2 to the power of 1 time. Here it is increasing 2 to the power of 2 times. That means second order.
Yes,
Suppose
sir.
third order is there. Then again rate is directly proportional to C is there. If I increase 2 times, the rate is increasing 8 times. Suppose that means 2 to the power of 3 times. I am increasing concentration only to 1 time, but rate is increasing 3 times. This is called third order reaction. Third order reaction. Generally, the representation will be like this: C to the power of 3. This 3 is indicating directly it is the third order. Here 2 is indicating second order. Actually, what is the meaning? The meaning is like this. If the concentration is increasing 2 times, then the rate will be increasing 2 cube times. That is the third order reaction. Clear now?
Yes, sir.
Order means?
Yes, sir.
So now rate is directly proportional to D. I am increasing 2 times the concentration, but here no change in the rate. I am increasing the concentration double, but no change. That means what can I write here? 2 to the power of 1 time I am increasing. No change means same concentration. So I can write 2 to the power of 0.
Yes, sir.
2 to the power of 0 is nothing but the 1 only. So this representation will be like this: d to the power of 0. Rate equal. Rate is directly proportional to d to the power of 0. This is comes under zero order reaction. Okay.
Yes, sir.
Right, zero order reaction. Now, some examples say we are increasing the reactant concentration, but rate will be the same. Which reactions it will be? A is giving the product. Okay, I am taking 1 m concentration initially. So per second, suppose 1000 molecules are forming. 1000 molecules are forming. So I am taking 2 m concentration. So it should be 2000 general our expectation, but still 1000 molecules only forming. That means the rate is not depends on the initial concentration. Okay, it is per second. Per second there is no change, even though I am increasing double concentration. So these type of reactions will be controlled by here some the presence. What is that presence? Generally in the presence of light, whatever reaction takes place in the presence of light, those reactions are controlled by the light. That's why those are not depends on the concentration. There is no increase in the rate. So these are comes under zero order reactions. Example, here light is there. Light means this one torch light or one slit of the light is falling. In this slit, how many rays are there? Suppose 1000 rays are there. Okay, what it is? Light. I am using this light, 1000 rays are there. Each ray is reacting with one molecule. The molecule is converting into product. This theory understood you? One slit is there, slit of the light.
Yes, sir.
In that 1000 rays are there. In the light, generally rays are
For
there.
each ray, it will give 1 mole.
No. Each ray means one particle is a photon actually.
Yes,
Each ray is one photon is giving. So this one photon is reacting with one molecule. It is react with one molecule. React with only one molecule. Okay. So how many photons are there here? 1000 photons are falling. If 1000 photons are falling, it will be react with 1000 molecules. Yes.
Yes, sir. So like a number of rays, it will those many number of molecules.
Yeah. Yes. How many rays are there? Those many molecules are reacting and converting into product.
Yes, sir.
So now I am increasing the reactant. Reactant initially maybe 1 mole means, so you can understand 1 lakh molecules are there. Reactant 2 mole means 2 lakh molecules are there. But the light is same. Here I am using the light is same. In this light, how many photons are there? Only 1000 photons are there. So how many molecules react per second? Only 1000.
Yes, sir.
Okay, only 1000 means only 1000 is the product per second.
Yes, sir.
So here the quantity of the reactant is not changing, not affecting the rate. The rate is depends on the light. Okay.
Yes, sir.
So in which reaction the rate is not depends on the concentration, those reactions are called zero order reactions. Generally these are carrying in the presence of light, zero order reactions. Okay. Now you can see rate equal directly proportional to a to the power of 0, rate equal to k a to the power of 0. The rate constant of zero order reaction is, so here simple derivations are there. Rate is directly proportional to a to the power of 0. I am writing for zero order reaction. Then what is the rate actually? Rate means A by T. What is the A? A is the concentration change, delta A, or I can say this one, dA by dt. This is the rate. D for delta, delta means change. Change in the concentration of A per time. Okay, equal to K A to the power of 0. Okay, this step you understood?
So over there, dA by dt, that dA meaning
Where
difference in the
dA,
A.
delta A by delta T.
So change in that A
A
compound
concentration.
with respect
Yeah.
to
Yes. Change in the A concentration
A concentration with
upon
respect.
time. How much time taking? Per 5 seconds or per 10 seconds or 1 minute or whatever the time.
Okay,
Change
sir.
rate
Yeah.
means what? Per time. What per time? Concentration change per time. That is the rate.
Yes, sir.
Okay. Now this is the first small changes. So if you want total, then we need to do integration. Mathematics, derivation and integration, do you know?
Yes, sir.
So integration, dA by dt. So this one I can write integration of dA equal to this dt, if it goes that side, k a naught, a to the power of 0 means what? A to the power of 0 means 1 to the power of dt. So integration of dA is a, then k means constant, constant will come out. What is this? 1 only. So integration of dt is t. This is the equation 2. In the integration, we will get some constant. Here, some constant we will get it. That constant is x I am taking.
Yes, sir.
Okay. Now, this is the equation 2. Integration, this much clear? It is very simple step. Integration of dA equal to a. Integration of dt equal to t. The k is there. K is the constant. The constant never change. So, k is as it is. Whenever we are doing some integration, here some constant will come plus some constant. The constant I am taking as x. Otherwise, you can write constant means constant only. Equation 2 is okay.
Yes, sir.
Now, this constant value actually we don't know. So, I want to calculate this constant x value. How to calculate? In this reaction, which reaction? The A is converting into product. In this reaction, when t equal to 0, then the concentration, what will be the concentration? See, when t equal to 0, the A equal to A0. What is the A0? A0 means initial concentration. Here A is the
Yes, sir.
concentration. When t equal to 0, A will be the initial concentration, right?
Yes, sir.
Then yes, put this value here in the equation 2. In equation 2. Then A, in place of A, it will become A0. That equals K into T. T equal to 0. So K into 0, that means 0 plus X. Therefore, X equal to A0.
Yes, sir.
Right. This value I'm substituting in the equation 2.
Okay.
So, what is the equation 2? This one. A equal to K T plus X. In place of X, I am putting A naught. Then, what is the KT? KT equals A minus A naught. Actually, one thing I forgot. See this one. The rate I written here, rate A to the power of 0, okay. But it is the minus rate, this one. This is the minus dA by dt. Why minus dA by dt? Yesterday, we discussed, whenever A is here, A concentration is decreasing now. When the reaction is carrying on, A concentration is decreasing.
Yes, sir.
So the decreasing symbol is a minus. If you write the product, we should take plus. When we are taking the reactant, the minus symbol should be.
Yes, sir.
So here it is the minus. Then it will be the minus here. Whenever it is a minus, then A equal to A naught, it's okay. It is a minus A naught. Then wherever X is there, X equal to what? Actually minus A naught. X equal to is a minus A naught. Okay. KT. Okay, minus A naught. Okay, equation 2, once again you can see equation 2, minus A equal to KT plus X. Minus A equal to KT plus X. X equal to minus A naught. Okay, this equation is nothing but equation 2 only. Understood?
Yes. Yes, sir.
Right. Now what I am doing, this A naught I am taking this side. Then what will happen? KT equal A naught minus A. Next line, when K equaled A naught minus A by T. Finally, this is the formula. K equal to the difference in the concentration upon time. You can see A0 minus A, the difference in the concentration by time. So this formula derivation I shown you there.
Yes, sir. So, sir, will they ask derivation?
We have to see the exercise questions. That's only maybe zero order, first order they may ask. They don't ask second order, but zero order, first order chances are there. Less probability, only 10% I can say. 90% they don't ask. Because numericals are there, so numericals only they will ask.
Okay, sir.
Even see, if it is not given in the textbook, means they don't ask. Order of reaction is there. Zero order reaction. This is the zero order reaction is given in this. So even though less probability, generally they don't ask in the board exams. So what I explained here, the rate is minus dr by dt. Why I am taking minus here? That is reactant. That's why the concentration is decreasing. That's why it is a minus symbol is there. Minus dr by dt equal to k r to the power of 0. As any quantity raised to power 0 is unity. Zero order. That's why r to the power of 0 equal to 1 minus dr by dt. Then this step you can understand easily. Dt and k obviously can multiply. No, dt I am taking this side. Dr equal to k into dt. Dr equal to k into dt. Minus is there, minus okay. Then what I am doing, integration, both sides integration. Integration of dr equal to r minus k as it is. Integration of dt equal to t plus I. I took it as x. Here I is given. What is I? Some constant. Here you can see. I is the constant of integration. Then how to calculate the I? What I am taking? I am taking as when t equal to 0 condition. If you t equal to 0, then what r will be? R equal to r0. Okay. If you put these values, then I am getting. Once I am getting I, this I value I am putting here in the equation 4.5 here. Then R is as it is, minus KT as it is. In place of I, R0, R0, I'm substituting. Then in the next step, this KT is going here, this R will coming here. Then KT equal R0 minus R. Then K equal R0 minus R by T. This is the formula. Got it?
Yes, sir.
So, what is this K here? K is the rate constant. A0, 0 down you can keep. A0 minus A by T. Okay, it is a one of the equation you need to remember for numericals. What is the K? Rate constant. Rate constant. For zero order. For zero order. Now, next questions, they will ask you half-life. Have you heard the word half-life?
Half-life. I think I saw it in P block chapter, sir. You had told that time.
Yes, yeah. Radioactive elements, those are having half-life time. Radioactive elements. Even if you take francium, hardly it will be around 2 hours or 2 like that. So what is half-life? If you take any one substance, if you take suppose 1 gram, to becoming half gram, how much time it is taking? That is a half-life. Example, simple example, if I am taking ice, 1 kilogram of ice. Okay, to becoming half kilogram of ice, how much time it is taking? Maybe 30 minutes. Okay, so this 30 minutes is the half-life of this ice. Understood?
Yes, sir.
But for understanding only I given this example, we cannot take this example. In the half-life, what it will happen? Half-life generally applicable for only radioactive elements. Radioactive elements. Okay. In the radioactive elements, here I took 1 gram. After some certain time, maybe 2 hours, it becoming half gram. This is the half-life of this X substance, X element, whatever it is. Here, in case of ice, what will happen? Here, water is forming. The ice solid will be there and water is forming. But here, the remaining half gram will be disappear. There is no any object extra. Disappear in the form of energy. As energy. In the form of energy, it is disappear. Okay, there is no mass, but it is converting into energy. Got it?
Yes. Yes, sir.
So the radioactive elements. So to decrease the mass up to half of that, the required time is called half-life time. Okay. In case of zero order, what is the formula for half-life? So we will calculate from this formula only. Now, what is the formula? K equal to A0 minus A by T. For half-life. What is the half-life? T equal to T of. Half-life symbol is T of. at t of what is the a value? A equal to a0 by 2. Hello.
It's equal to
A0 by 2.
by.
What is a? Means after half lifetime. What is the a
Yes, sir.
concentration? This is the C. 0 means it is the
Oh,
initial
yeah.
concentration.
Initial.
It is the final
Yeah.
concentration. What will be the final
Yes.
concentration? A final is nothing but a initial by 2.
So that is, we can say by 2 only if the time is half, right?
Yes, because half life in the meaning only half hona chahiye.
Okay. Okay. Yes, sir.
Okay, so the formula is k equal a naught as it is minus a. In place of a, I can write a naught by 2 by t, right? T of,
Yes, sir.
T of, here T of. Okay, so I'm doing LCM, then 2a naught minus a naught, that means a naught only, a naught by 2. A naught by 2, then into 1 by T of. Okay, so I can write it like this, a naught by 2T of. Okay, so this formula only I can write T of equal to. T of equal to, I am taking T of here, then K down. A naught by 2K. This is the final answer, final formula. T of equal to A naught by 2K. What is A naught? A naught is the initial concentration upon 2K. K is the zero order rate constant. Understood?
Yes, sir.
So here this formula is important. If you know this formula, then you can do this T of. How this formula we got it? From this. This is actual formula. How we got this formula? From the derivation. If you remember directly, that's enough. 99% no chances to ask derivation, but these formulas you need to remember. So numerical they may ask. So zero order completed. Okay.
Yes, sir.
Now first order. Okay, in the zero order still graphs important here. Graphs very important. So what is the formula? K equal to a0 minus a by t. Okay, nothing but here r. I took their a, here they are taking r. That's the only difference. Okay, K equal to r0 minus r by t. This is the equation, right? Here, this formula, I can write it, the concentration of r versus t. That means I can write Kt equal to r0 minus r. Then R I'm taking this side, Kt on this side. So R equaled R0 plus Kt. This much can write from this. Yes. See, this is the formula. This formula is clear first of all.
Yes, sir.
So from this formula, this step I can write it. Just I did it. T, I took it here. That's only.
Yes, sir. So
These are multiplying, na? K by 1
yeah.
R naught minus T. Okay. This step is clear now?
Yes, sir.
So after that, what I'm doing, this R, I took it here, then K2, I took it here. Exchange. This formula is okay?
Yes, sir. Yes, sir.
Then, sir, why you are writing these? Yes, that is a doubt. So I am writing in the form of y equal to mx plus c form. y equal to mx plus c form I'm writing. I did little mistake. Okay, here it should be minus, right? Minus kt, because the kt is going this side means minus kt. Minus r coming this side means plus r. Plus r I
Yes.
written r0 and minus kt. Okay, then this one y equal to mx plus c. So y I am taking on y axis, r concentration. X means what? T. T I am taking on x axis. Then what is the m? M will be the slope. Then this r0 is the some constant intercept. That means the line will start after r0 distance, 0 to r0, and the line, the slope will come whenever negative is there, the slope will come downside. If it is plus k is there, the slope will go up. Plus k is there. If minus k is there, the slope will go down. These are the symbols and mathematical also. Okay.
Yes, sir.
So y equal to mx plus c form is there. Then y on y axis, x t on x axis. The m will be the slope. What is the slope? This is the slope. Slope formula y2 minus y1 by x2 minus x1. y2 minus y1 by x2 minus x1. Yesterday somewhere we did that. Instantaneous rate. In that case, we did like this. Okay, slope. The line, how it is going? Is it going up or down? That is depends on slope. The slope is negative. Negative means the line is coming down. Okay, this graph is clear.
Yes, sir.
Now first zero order is completed. Now first order. Similarity is there. Similarity is there. Then see rate. What is the similarity? I will write it here. Minus dr by dt equal to, we written for zero order, r to the power of 0 we written. Same formula. Here r to the power of 1. This is the first step difference. Right?
Yes, sir.
Then r to the power of 0, there it was 1. That means only k into 1 k. But here k into this r. Same terms I'm taking one side. Dr by r. This dt is going that side. So this step I can write it. What I did, minus dr upon dr upon r only r upon r. The k is there, this dt. Okay, the second step is clear.
Yes, sir.
Then next, what is that? This derivation. So integration we have to do both sides. Now integration, some formulas you have to know. That integration of 1 by x equal to
1 by x will be log x.
yes, log x. So here logs are two types. One is normal log and some another one is ln. Ln means natural logarithm. Natural logarithm. What is the difference? This log is log base 10. Natural logarithm is log base e. Logs, two types are there. Okay. So in the chemistry, always we will take natural logarithm only. So the symbol is simply ln we will write. Formulas are same. Integration of 1 by x log x, here ln x. That is only the difference. The base only different. Formula is same. Okay, I am doing integration for this. Now integration here and this one. Minus k t plus I, it's okay this side. Here integration of 1 by x equal to ln x. So this formula is clear. This step will be clear.
Yes, sir.
Right. Now here process is what I we need to calculate. We don't know the I. So for that what we are doing, I am taking t equal to 0. At t equal to 0, r equal to r naught. Because reaction is not yet started. T equal to 0 means. Okay, that time R means here not rate, R means here reactant only. The reactant concentration is R0. The 0 is indicating always fresh. Okay, initial. Is it okay? T equal to 0 means
Yes.
R equal to R0. Then these value put it in this equation. Then I we will get it I equal to ln R0. Then this ln R0 value, put it in this equation, we are getting this equation. This much clear now?
Yes, sir.
Right. After this, we need to write the formula. So I can write it here. ln R minus ln R0 equal to minus KT. Right. Log A minus log B equal to?
Log A by B.
Yes, log A by B. So log R by R naught. This step is clear.
Yes, sir.
After that, if you want only K, then the T will come this side. So then K equal to 1 by T ln R naught by R. This is also clear.
Yes, sir.
Okay, this is the one of the formula. K equal to 1 by T. See, natural logarithm is ln. Normal logarithm is log. What is the relation between these two? ln equal 2.303 into log. The base 10, here log base E. Do you know this? Natural logarithm, if you want to convert into normal logarithm, you have to multiply with 2.303. Okay?
Okay, sir. I didn't know this. Also, so in that step, what happens to the minus sign?
Here.
Yes, sir. Like after that, when to the next step, the minus sign.
Okay, I will see this. ln, what they did, R by R naught, they written ulta, R naught by R.
Oh, okay. So they brought K this side and they took that to the other side. That's why. Okay.
When we are changing
Yeah.
up and down, one minus will come. The minus and minus plus. Minus and minus get cancelled.
Okay, sir.
Okay. So now log here K equal to, I can write it. This formula only I am writing little difference. 2.303 upon T log R naught upon R. What I did, just natural logarithm, I converted into normal logarithm. That's only, this is the step. This is the one formula for numericals. We will use this. It is the first order one. Okay.
Yes, sir.
Same formula. Now, sometimes if the time is given at 20 minutes time, this much reaction is there. At 30 minutes time, this much reaction is there, they given. So in that case, what we need to do? Sir, two times are there, 20 minutes and 30 minutes. What should we take? Actually, the meaning is what here? T per time. So what is the duration of the reaction? The duration of the reaction is 20 to 30. That means the difference, only 10 minutes reaction carrying. Yes. At 20 minutes, suppose initial R naught is there. At 30 minutes, concentration R is there. The reaction carrying how many minutes? 20 minutes or 30 minutes or 10 minutes? From R0 to R.
R02R. 10 minutes, right?
Only 10 minutes. How we got it 10 minutes? Final time minus initial time. That means T2 minus T1.
Yes, sir.
So sometimes if the question is giving 2 times at this concentration is at this time, this concentration is there. At another time, this concentration is there. So in that case, this formula little bit changing, modifying. The T in place of T, we are writing T2 minus T1. There is no change remaining as it is. Okay, this formula clear?
Yes, sir.
Next. So what I written there is the same formula they written here. K equal 2.303 by T log R0 by R. Then log R0 by R equal to this T is going there, then 2.303 coming down. This is also we can write it. Formula is only one. However you want, you can write it. That is why they are writing like this, because sometimes they will ask the graph log R naught by R versus time T. Then we need to take like this, y equal to mx plus c. Here c equal to 0. Mx. M is the, x is the t, m is the k by 2.303 slope. These are for the graphs. Generally JE, they will ask this type of questions. They will give the 4 graphs. Which of the following graph is incorrect or correct? Like that they will ask. Okay, so from this, if you want, you can write like this also. This step is clear?
Yes, sir.
Right. Now, see the advantage. This is only. What was the formula actually? I'm writing once again. K equal 2.303 by T log A0 by capital A, A0 by A. This was the formula. So, ln R, this one first. Log R naught by R. Okay, A naught nahi, R naught take it. R for reactant. Log R naught by R versus time. They are taking the graph. So this formula you need to make it like y equal to mx plus c form. Y equal to mx plus c form. Then what to do? This term as it is remain. The t is going there, kt. Then kt equal 2.303 log R0 by R. This step is clear from this?
Yes, sir.
So in the next step, what can I do? This 2.303, I can take it here. 2.303 down. Kt by 2.303 equal to log R0 by R. Okay.
Yes, sir.
Now it is y equal to, sorry, this is a y equal to, it is mx plus c. Here there is no c. C equal to 0. Y, I am taking on the y axis. What is the y? Log R naught by R. It is the y. X, mx, x is the t. X is the t. If I see, I am considering it is as mx. In this mx, x is the t means, what about m? M will be k by 2.303.
Yes, sir. Yes.
This is the total mx means x is the t, the remaining part is m is the constant k by 2.303. You can see here slope k by 2.303.
Yes. Yes, sir.
Now in this formula, y equal to mx plus c, the m is the slope is the positive. So the line is going up. And mx plus c, c equal to 0. That means intercept is 0. When intercept is 0, the line is going through the origin. Okay, this graph is clear?
Yes, sir.
Right. So how this graph is there? So if I don't take 2.303, same formula again I'm writing. K equals, what is this formula? ln. K, this t I'm taking this side. Kt equal 2.303 log. That is nothing but ln. ln r naught by r. This formula okay? Kt equal ln r naught by r.
Yes, sir.
Okay, but I want here only ln r, right? Log a by b equal to, what is the formula?
Log A by B. Log A minus log B.
Log b. So kt I am writing as it is. Kt equal to ln r naught minus ln r. Okay.
Yes, sir.
So here ln r is the changing because it is the final concentration. Initial concentration never change. No? Initial concentration once we are taking it, that is initial concentration is a constant only. Right? So here this is the y-axis. Okay, same again, this formula again I'm writing. Now this ln r I am taking this side, kt I am taking reverse. Ln r equal to ln r0 minus kt. Okay, this formula okay.
Yes, sir.
Now it is a y equal to, it is a mx, it is a c. Now y, I am taking on the y-axis, ln r, it is a y. Then c is the constant intercept, ln r0. This distance is ln r0. Then t on x-axis. What is the slope here? Minus x is the slope. Yes, minus x is the, minus k is the slope. Minus k is the slope. This is the x-axis over. Okay, minus is there, that's why the graphical line is going down. Right?
Yes, sir.
Then k, the slope is k. The slope is there, that is the k. Okay, two graphs over in the first order reaction.
Yes, sir.
Now once again I am writing the k equal to 2.303 by t log a0 by r0 by r. This was the formula for first order.
Yes, sir.
Now I am writing for half-life. If I write for half-life, t equal to t of, at t of, r will be r0 by 2. Yes or no?
Yes, sir.
R means final concentration. The final concentration equal to initial concentration upon 2.
Yes, sir.
So these values put it in this. Then K means as it is K 2.303 by T means T of log R naught as it is upon, in place of R, R naught by 2. This much clear?
Yes, sir.
So here R naught and R naught will get cancelled. So this 2 will go up because R naught by 1 upon R naught by 2, A by B into D by C. So what it will be, that K equal 2.303 by T of log 2. Okay, this term is as it is. Here R naught get cancelled, the 2 is going up, so log 2. Is it okay?
Yes, sir.
Log 2 in the last second class, I think we discussed log 2 value 0.301. If you multiply this, simply third table, that means 3 3 is 9, 3 2 is 6, 6.9. Okay, K equal to 6.9 it is 0.3 is there, so 0.69 upon T of. Is it okay?
Yes, sir.
So in the first order, rate constant will be the constant because TF is a constant. So K is the constant only, K equal to 0.69 by TF. This is the one of the formula for a half-life we need to remember.
Yes, sir.
Now, first order we discussed, okay, but first order, which reactions are comes under? In the zero order, I told you light reactions, photochemical reactions. But in the first order, what are the examples? In the first order, all radioactive elements. All radioactive elements are comes under first order. First order. Okay. Right. Now,
Yes, sir.
so half-life formula is over now, right? So one numerical you can see. The initial concentration of N2O5 in the following first order reaction is given. This one was 1.
Sir, sir, I
Hello.
have another next class in 5 minutes.
Okay, right. Okay, tomorrow we can discuss. Once you go through this, at least
Yes,
start
sir.
doing exercise question, at least exercise index you do it, then only you can understand easy.
Yes,
Okay.
sir. Okay.
Okay.
Yes, sir.
Bye. Good night.
Bye, sir. Good night. Thank you, sir.